We're going to be looking at how to do cross sections of three-dimensional shapes. So what 2D shapes would form 3D shapes and vice versa. So if you look at the example on the top of the front page, you'll see kind of a revolving door that you might see in a building. And the idea is there's two pieces that make up this revolving door. There's the door itself, which is the 2D shape, and then by rotating that door, you get the 3D shape, which is a cylinder. So again, we're trying to make the connection between if we rotate a 2D shape, what 3D shape would come out of it. So we're going to look at some examples. So right now I'm at the bottom of that front page for 8.5. And kind of like the example we just looked at, it says determine a 3D solid that would be formed by rotating it. So basically what you would do is take each point and imagine making circles at the top and bottom of each points and thinking about what shape would be formed by it. So like for number 1, this is the one we just talked about, this would be a cylinder. Now like with the second one, same thing. This is going to be pretty close to a cylinder. It's actually going to have two pieces to it. There'll be two, more of like a hollowed out cylinder for number 2. And again, I'm not the best artist, and I'm sure if you're not either, it's going to be hard to draw. But again, this is kind of like this would almost kind of be like two cylinders, or you could call it a hollowed cylinder. And then with this third one, if we take this center part that's sticking out, that vertex, and kind of draw it out, in this case, this kind of looks like two cones, where you have one cone on top, one cone on the bottom. So really for these, and the examples on the second page, just draw it as best you can and then describe it in the matter of the 3D shapes that we've talked about. So I'm going to go ahead and erase that, and we're going to go to the back of this page, and we're going to look at the top problem on the back, which is trying to relate the cross sections to the actual volumes of the shape. So like if you look at question 1, they give us a cross section of the cylinder. And this line in the center right here represents that rotational point. And they're asking us about the height and the radius of that cylinder. So if we look at the height of this cylinder, the height would be this side, which would be 3. And the radius, again, if this was a cylinder, this was drawn out, the radius would be equal to this line, which in this case the radius would be 4. So if we use the volume to calculate, the volume formula to calculate this, this ends up being, for volume, it'd be pi radius squared, which is 4 squared, times 3, which in this case would be 48 pi. So now what we're going to do is we're going to look and see if there's some relationship between the cross section and the volume. So if we look at that rectangle, so now we're just focusing on the 2D shape, this rectangle right here. So they want us to figure out the height, the width, and the area. So the height in this case is 3, the width is 4, and then the area would be 3 times 4, which would equal 12. So for the final part of the question, I had to move that down. We have the area, which is 3 times 4, which equals 12. So in the case of that relationship, the relationship for the area is just going to be whatever the radius is times whatever the height is. So the radius times the height. So, and again, that would be the same for any cylinder created by this. So when you're working on the assignment and you look at pages 3, which has some of the shapes that we just talked about, again, try to think of them and see them three-dimensionally, okay? When it says name description, give it a description as to what 3D shapes you see. And then the same thing we talked about, if you look at pages 4 and page 5, sorry, on page 4, they want you to do sketches also.